You're listening to the N2K Space Network.
Hi there. I'm Maria Varmazes, host of the T-Minus Space Daily podcast, and you're listening to T-Minus Overview. In this program, we'll feature some of the conversations from our daily podcast with the people who are forging the path in the new space era. From industry leaders, technology experts and pioneers, to educators, policymakers, research organizations, and more. The International Space Station has been in continuous operation since November 1998. It is the largest modular space station in low Earth orbit, traveling at an average of a mere 17,500 miles per hour, 250 miles above the Earth. Living up to its name, the International Space Station, or ISS, is a global effort that involves 5 space agencies: NASA from the United States, Roscosmos of Russia, Japan's JAXA, Europe's ESA, and Canada's CSA. The ISS is primarily a lab space where science experiments can be conducted in microgravity. And there have been some amazing scientific breakthroughs on the station in the last 25 years or so. But in 2030, it's coming to an end. So what's going to happen once the ISS is gone? And what might replace it? We'll explore that a bit in this episode, where we're going to take a look at the commercial low Earth orbit destination market and beyond. Our first guest is Steve Wolfe. Steve is the president of the Beyond Earth Institute, a nonprofit think tank that is focused on policy and regulatory issues that will help us get closer to a future where humans can live and work in outer space. Steve is spearheading the commercial low Earth orbit destination program. And we started our chat with me asking him, quite simply, to explain what that means.
The Commercial LEO Destination Program, we call it CLD. It was a program that was initiated by NASA. It was created because we recognized that the International Space Station is going to come to the end of its useful life sometime by the end of this decade. And NASA has made the decision, and many people think it's the right one, that NASA should turn over LEO activity to the private sector and turn its attention to deep space exploration. So you're familiar with the Artemis program, where we're going to go back to the moon to stay and then go on to Mars and explore Mars. And those are exciting things that NASA should be doing. And it's reached a conclusion that after 20 years of operation of the ISS and all the experiments that they've done, that they've helped to develop and foster commercial capability in low Earth orbit, and they want to turn that over. So what the CLD program is they've identified, I would say, 4 providers, companies that will build habitats in low Earth orbit that would serve the needs of NASA in low Earth orbit with shirt sleeve astronauts to continue to conduct the kind of research that they were doing on the ISS. In addition, these private operators of these space stations would also now be able to go to and develop other markets of other folks to come to their space stations along with NASA to develop whole new markets of activities on these space stations. So it's really an exciting new transitional moment in history, which, if it all comes off right, so that's the tricky part.
That's a big if.
If they can make this transition properly, and if there are the markets that NASA, or I should say that the private sector is hoping to develop, it will be an exciting time. The 2030s and 2040s will see this dramatic increase of the numbers of people that are going into space, into low Earth orbit, to be as scientists, to continue to do scientific experimentation, as industrialists, to actually go up there and manufacture interesting and new kinds of products that can be brought down to Earth and utilized in markets on Earth. And of course, not the least of which is the opportunity for humans to go into space just for the experience, right? Space tourism, people talk about that a lot. So those are the three big buckets of categories that all of the private space station providers are now eagerly seeking to develop.
I remember when I was sort of thinking about this program, the CLD, my initial impression was it's not that NASA's going, we're done with LEO. It's saying we're going to partner with the private sector, but we're going to concentrate our efforts beyond LEO, right? That's really what the emphasis is on this, is commercial space can do LEO, and then NASA's going to do its thing kind of beyond.
Exactly. So NASA is going to continue to do research in LEO. It needs to do that. There's a lot of important research as part of their mandate to do, and LEO is a great place to do a lot of for the sciences and so forth, and advancing all that. So they're going to be a tenant, right? They're going to rent space in these facilities, and they'll have so much space, and they'll negotiate the terms and so forth with these private sectors. The same way the government might rent space in a building anywhere to serve its needs. So that's the model. The challenge is going to be making sure that this whole transition is successful, right?
Right. Yeah. So, that if that we were talking about earlier.
Yeah. There is an if there, and there's two big question marks here. Okay. So first is money from the government. So NASA has committed a certain amount of seed money to these commercial space station providers. They're expecting these stakeholders to then go also to the capital markets to raise additional funding to help to build and deploy these things. So NASA's not paying the full freight. So there's a risk there, right? There's automatically a built-in risk there.
That's risky, yeah.
But, NASA needs to take the position that regardless of what happens, there needs to be that capability. I truly believe at the end of the day that NASA needs to do whatever is necessary to make sure that this capability is there. And so maybe we might not have 4 separate facilities, okay, but we need this capability, whatever form it could take. So there's that challenge. The other challenge, and this relates to the private players being able to raise the money, has to do with the markets, right? How quickly those markets might be able to mature. And that's the challenge, because we're, in many sense, you're talking about a very, very new and nascent potential here, right? And it's still expensive, right? The cost has been coming down, thanks largely to SpaceX and Falcon 9, but it's still very, very expensive. So, for example, Axiom has a ticket price of taking passengers up to the space station right now, $55 million per launch. It's just not, except for the very, very wealthy or as an investment model, that's a big chunk of money. So there's that challenge. And again, we're anticipating things like SpaceX's Starship that ultimately could be a big game changer once it's operational.
Fingers crossed.
Fingers crossed, right? So that's the challenge. It's a bit of a race that's going on right now. So NASA's ISS is retiring. We don't want a situation where the ISS is decommissioned and it's deorbited and we don't have that commercial capability yet, right? So that's the last thing that we want. That was kind of the situation we had with the space shuttle, where the space shuttle came to the end of its life. And once that happened, the U.S. had no capability of launching astronauts from U.S. soil up to the space station, and we had to rely on the Russians. So we don't want, we don't want any kind of repeat of that kind. So that's the challenge. It's a big challenge for NASA. It's a big challenge for industry. And we maintain that CLD must not fail, right? There has to be a decision that, whatever happens, it cannot fail. We need this capability. And it's a matter of national security, frankly. We know that the Chinese are aggressively moving into this capability. Other nations are talking about putting up space stations. And, the U.S. cannot be left behind on this, whatever it's going to take to make this happen. So that's our position.
One of the commercial companies working on producing a private space station is VAST. T-Minus producer Alice Caruth met up with David Caponio from VAST to ask him about their plans for the commercial low Earth orbit destination market.
I'm David Caponio, the Senior Vice President of Product and Business Development at VAST. Well, we're a relatively new company, founded just about 2 years ago, with a vision of creating an artificial gravity space station. Last May, we announced our first space station called Haven 1. It's a single Falcon 9 module space station to be launched by August 25. And then to be shortly thereafter crewed with a 4-person crew from SpaceX Dragon launch, and then a total mission lifetime of 3 years with 40 days of crew time spread out over 4 missions.
Wow.
Yeah.
So you come in at an angle that other companies aren't doing in that CLD area of bringing in artificial gravity. Why are you doing that? What's the benefit of having that artificial gravity environment when others are looking for microgravity for experiments, for example?
That's true. When we had our first conversations with NASA on artificial gravity, they were ecstatic. This has been a dream for them for the last 2 or 3 decades, since the early part of the ISS, to have some sort of artificial gravity generation on a large scale. They do have centrifuges on board, but this would be, full life-size human-rated centrifuge in space with the whole entire space station. And we did this, like I said, it's the vision of the company. The founder, Jed McCaleb, who's our single founder and funder of the entire Haven 1 plan and through the future, did this because one of the major challenges of humanity living in space is the detrimental effects of microgravity. Everything from bone loss to muscle loss, even brain effects, the octave nerves. There's just been a whole host of study in microgravity on deleterious effects of microgravity. And the only way to solve that is with artificial gravity. So we do that with centripetal force, simply spinning the spacecraft. It's no simple feat, of course. So we're going to be taking an incremental approach. And with Haven 1, even though it's a crewed space station, there's uncrewed portions. They're quite lengthy, where we'll attempt to perform an uncrewed demonstration of artificial gravity. Even at a space station of that size, we're able to generate up to 1/6 gravity, which is the gravity found on the moon. We'll have an entire ISS express rack that will experience 1/6 gravity for a period of about a week, and basically will become a lunar test bed that you can do in LEO earlier and at a fraction of the cost.
So tell me about your customer base. If you're going to be creating this artificial gravity base in LEO, who is it you're looking to attract to get out there?
Well, the unique part of our next space station, which is kind of a working title, we're just calling it STIC for now, it would be a Starship class, 7 meter in diameter, 7 modules all linked together on a 100-meter span. Spinning that end over an end like a baton allows you to generate 0G in the center, obviously, and then up to 1G at the ends. And then between that, you get variable gravity hitting, of course, lunar gravity, Martian gravity, even Venus, and then all the way up to eventually 1G. So it allows for a gravity laboratory, basically studying the effects of gravity on the human body. We know a lot about 1G. We know a lot about 0G. We don't know much about anything in between other than, 2 weeks on the moon 6 times. So it allows us to kind of do that quite easily in LEO. It's still in a zero microgravity environment, testing variable gravities, all the way up through 1G, and really testing, if we do Martian expeditions, 6 months to get there, 18 months on planet, 6 months to get back, and then you're at a third of gravity while you're on planet. Is existing in 1G during the transit enough to then, exist at 1/3 G for another 18 months, or something maybe a little bit higher, like over 1G, 1.1, 1.2. Does that kind of supercharge us to then be on planet at a lesser degree, which we have obviously can't be in a centrifuge when we're on planet, and then allow us to come back maybe at that accelerated gravity and then be back at Earth at a relatively less affected state.
Fantastic.
So yeah.
What a great idea. Now, you kind of alluded to it a little bit. You are working with NASA. Can you talk me through that agreement that came out earlier this year?
Yeah. So we were founded just after the selection of commercial LEO destinations. So that, of course, is a funded Space Act agreement with the three selectees. And we did not propose to that, obviously, because we didn't exist at the time. But just earlier this year, we were selected for the Collaboration and Commercial Space Capabilities, Part 2, one of 7 awardees. Even though that's an unfunded Space Act agreement, it does allow us to start the conversation with NASA, to develop the relationship, to do initial data exchanges with a lot of lessons learned from ISS, potential access to NASA testing facilities, and potentially NASA services like communications from TDRS. So we're very excited to get going. We had just kick off a few months ago, brought us NASA folks down to our shop in Long Beach. We have 115,000 square feet of integration and workspace there, and kind of showed them our plans and our vision for the future. So
you're very much a future vision company, and you've got a roadmap laid out for that. Can you tell us a little bit about that roadmap and what VAST is looking to do? Yeah,
so we talked a lot about Haven 1, talked a little bit about our future space station, but also on that roadmap there's another incremental step. As we're a young company, we want to practice in space first. So we have a demonstration mission planned with a small spacecraft, uncrewed, unpressurized, we call Haven Demo. That will test a lot of the early, initial avionics that we have, kind of the backbone of our space station, some of the low heritage systems, get those, space heritage up to Tier L9, and ready to be incorporated into a crewed spacecraft. And then, incorporating, like I said, the small artificial gravity test on a small scale and an uncrewed, shorter duration, and then eventually incorporating that into a larger space station full time.
What a very exciting time for you. You touched on in-space manufacturing. Is there anything else you're really pushing for and looking forward to in the future of the aerospace industry as it's starting to really take off right now?
So we're kind of looking, as NASA and all of the CLD providers is looking for that killer app. What makes sense on the manufacturing side to do in microgravity or other, partial gravities as we talked about. And we're really challenging the industries, But the leading candidates would be pharmaceutical, semiconductors, but really broaden the area outside of the space industry and how can Earth use microgravity and potentially artificial gravity to do things in space and bring them back down to Earth to have, a multiplicative effect that you can't do in 1G. So we're excited for that. I think, with the... We're now looking towards the end of the International Space Station. It's been an incredible opportunity as a laboratory that's been, highly subsidized by international space agencies. But now we're challenging the industry to really formulate that business plan. What makes sense? How could you get to a good bottom line of profitability to do something in space? And with us, it's finally the first commercial opportunity to really do that. So we're excited for that first kind of spark that would start the commercial LEO economy. We see, definitely there's promise here and there, and folks kind of just, getting to a point where it's making sense for them, and we just want to apply that platform to make that opportunity a reality.
So we've focused on the low Earth orbit market so far, but what about beyond that? And yes, there is a beyond that. And that would be what's called cislunar. It's a term that refers to the area between the Earth and our nearest natural satellite, the Moon. This 240,000-mile distance is a fascinating new market for commercial space companies, but not without its own challenges, of course. So, what's the potential for commercial markets in cislunar space? To learn more, I spoke to Ron Birk from the Aerospace Corporation about this emerging market.
Hi, my name is Ron Birk. I serve as the Principal Director for the Space Enterprise Evolution Directorate at the Aerospace Corporation. Overall, my responsibilities are focused on the future of space, the areas where the space enterprise looks very different into the future. As I like to say, I focus on areas that look very different through the windshield and through the rearview mirror.
That's a great way of putting it. Ron, thank you so much for joining me today. I'm really thrilled to be speaking with you. There are a lot of topic areas I know I could ask you about. I'm going to do my best to just focus on one of them today. And that one is cislunar. It's been in the news a lot. It's been in even like the mainstream news. I was reading some stories in the New York Times recently about the grand plans for cislunar. And before we get to any of the, the ideals of what one day like a lunar economy might look like, there's a lot of groundwork that needs to happen to develop what cislunar is going to look like. And I know this is something that you're deeply involved in. Can you give me sort of like the pitch for where we need to be going to before we get to the end goal, so to speak?
Recognizing that cislunar is a greenfield in space, largely undeveloped. One of the things that we recognize is that to achieve the sustainable cislunar ecosystem that's called out in our national cislunar strategy, we're going to need a number of foundational layers of infrastructure to be put in place. And we've been looking at that and coordinating across the community, and we've identified 12 foundational layers of infrastructure that are going to need to be put into place. And we've also identified over 80 companies that are planning to build and deploy, operate over 100 systems aligned with those 12 layers of infrastructure in the coming years.
The focus here is on U.S. or is this more global?
So the focus is on U.S. and allies.
Mm-hmm. Okay, excellent. So when I think about cislunar, I just kind of have a hard time imagining how we get there from here, where we're at right now. It does seem very aspirational and it's wonderful. I'm kind of like, how do we get started on this? What's the next step?
It's only 240,000 miles, so it's not that far.
No.
So the way that we get started is we recognize that there are plans to put up 4 layers of infrastructure, starting with communications and navigation, and that launching the systems that have the engineering capacity to be able to deliver that functionality has been demonstrated. The challenges are predominantly in verifying that those capabilities will not only deliver the functionality that they're intended to deliver, but that they'll work in the cislunar domain, which has some very different attributes. The environment has very different attributes than even the low Earth orbit environment has, right? There are differences in radiation exposure, lighting is different, etc. And so there has to be a proving out of the capabilities to operate in that domain. And there also has to be the establishment of interoperability between the capabilities that these individual companies and government agencies are planning to deploy and other elements of the ecosystem, other systems that represent other infrastructure layers. So the comm systems need to be able to work with the power systems, need to be able to work with the in situ resource utilization systems, et cetera. So that's one of the more near-term challenges is beyond the development of the technology to achieve the functions of these infrastructure layers, we need to work out their interoperability and ability to be able to work in the environment, the very different environment of the cislunar domain.
Yeah, as you mentioned that, I recall a comic by XKCD about the establishing standards, and then someone goes, I want to establish a new standard, and now you have an extra standard. I'm badly quoting the comic, but it's a big challenge here on Earth for interoperability to be achieved. And I'm imagining, in a situation where we can't go visit it in person ourselves, most of us, so that is going to be an interesting challenge. It feels almost overwhelming to think about a task this big. So where are we right now? Like who's working on this problem right now?
Wonderful question. The AIAA last year established the Cislunar Ecosystem Task Force as a platform for companies and government agencies to come together and share information that's necessary for coordinating at an engineering level the interoperability of their systems. So that has made significant progress over the course of the last year. There are 15 working groups within the structure of the AIAA Cislunar Ecosystem Task Force. Many of those working groups have been stood up with co-chairs and members and are underway with their coordination processes and practices. There's two other groups that are underway with coordination. One is the CONFERS Consortium, which is a trade association that is focused on compiling best practices and lessons learned associated with what will be needed as standards. So CONFERS members come together, compile best practices and lessons learned, and then those compiled recommendations are submitted to a standard development organization. And there are several standards development organizations that CONFERS works with, including the International Standards Organization, the ISO, as well as AIAA. So they also are working in this space, having recently extended their domain from a focus on LEO for many years. Their focus is now extended to cislunar and beyond. And then the third group for reference is the Space ISAC, the Information Sharing Analysis Center, which has a focus on bringing together companies and approaches for sharing information. And one aspect of the cislunar domain, people have noted that data is actually going to be the coin of the realm in cislunar. So having the ability to share data across the community efficiently is very important. And the Space ISAC community is working on that. Over.
That's fantastic. Yeah, I can absolutely imagine that being the case, and especially keeping that data secure as well, I imagine would be a huge priority as well. Absolutely. This is sort of a soft question, but I am curious, like, how are you feeling about the prospects of how this is going? I mean, I'm not trying to downplay it is a very exciting challenge, but I imagine it's a daunting one too. So how are you feeling about it?
Feeling really, really good. It is a daunting challenge at several levels. One is that it does take a critical mass of capability to be able to get to a sort of a minimum threshold of an operational ecosystem, which indicates that several different companies and government organizations are going to need to be able to successfully deploy their comm systems, their nav systems, their sensing systems, all in a similar time frame, so that we get to what we refer to as a go green status, right? That there is an initial operating state of multiple individual functional capabilities that can all support the other, right? So that's both feeling very good that there's as many people and players as there are in the space, and also recognizing the challenges of actually enabling all of those players to come forward. A relative area of trepidation is that as for the space enterprise rightfully looks for TRL level 9 capabilities, systems that have actually flown in space, to be deployed in space for operational purposes, there's a fairly significant amount of capability that has not had that opportunity to be flown in space. So an enabling area for the space enterprise is test beds and proving grounds that will allow systems and capabilities to be demonstrated and for trust and confidence to be built up in those on their path to being deployed for an operational utility in an ecosystem environment.
Thank you to our guests, Steve Wolfe, David Caponio, and Ron Birk, for sharing their insights with us today. And if you're interested in hearing more about the space industry, join me every day for T- Space Daily. It's available on all major podcast platforms. You can find out more at space.n2k.com. We'd love to know what you think of this show. You can email us at space@n2k.com. And your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. This episode was produced by Alice Carruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Jen Iben. Our Veep is Brandon Karp. And I'm Maria Varmazis. Thanks for listening.